Hello and welcome. This is a series of videos related to the Physics 101 final exam of Princeton University. My name is Jerry and I'll be going over ideally every question of the exam. So this is number 3, and it states a man of mass m equals 75 kilograms lowers himself down from the top of a building by using a rope wound on a drum. A hollow cylinder of radius r equals 0.5 meters and mass 2m equals 150 kilograms, and that relates to double the mass of the man. As shown in the picture, the man and the drum start at rest. A. Find the angular acceleration of the drum, and B. What is the velocity of the man when he has dropped 20 meters? Now, to begin, we can put the known values here. We have 75 kilograms of the mass, we have r is equal to 0.5 meters, and we have, this is small m rather than big M, it is double the mass of the man. 150 kilograms. And for these three equations, I looked in the sheet that they gave from Princeton University. So we have I hollow, and you can find that in the middle of these equations. I hollow cylinder is equal to mr squared. We also have the two torque equations. We have one in the middle left, F times L times sine of theta, and we have one in the upper middle right. The sum of torque is equal to I, the inertia, times the angular acceleration. And we also have that A acceleration is equal to R times angular acceleration. So we're looking for angular acceleration. So these equations will help us get there. Now, the easiest way to begin is to simply find how the forces are interacting in this problem. Now, the sum of the forces on the man is going to be m times g minus the tension. And now mg is simply the man and gravity pushing the man down, while t is the tension of the rope pulling the man up. So we can simplify that even more, or we could also realize that force is going to be equal to ma, the mass times the acceleration. So this would be the acceleration that the man falls down. Okay, so now let us isolate t. So t is going to be equal to ma minus mg, which would be equal to m times a minus g. So that'll be the first part. This is in section A. And now let's work with the torque. So we have torque from the equations equal to I hollow, because we have a hollow, it's mentioned there was a hollow cylinder, is equal to FL sine of theta. Now L is simply going to be R in this case, while sine of theta is simply going to be 1, because this is going straight down. While the F in this regard is going to be the tension. Now I hollow, we had earlier, so let us start plugging things in. Just give it a torque, that's not really important here. So I hollow, let's just keep it as I for now, is going to be I times the inertia times the angular acceleration, and let's plug in the tension. So m times this would be g minus a rather than a minus g times r. Okay, one other thing to realize is that a is equal to angular acceleration times r. So let's plug that in as well. Okay, and now let's simply simplify it and isolate the angular acceleration, because we know what the g is, we know what the mass is, we know what the inertia is, and we know what r is. Okay, so the easiest way, let's just get this done. Mg minus mr times r, so r squared. Let's put the value of the inertia, which is mr squared. And gr minus mr squared. Get rid of this, get rid of that, get rid of this, get rid of that. Okay. So this will simply be mg, well, gotta get rid of the m's, is equal to g minus alpha r here as well, 2r alpha g, the alpha is going to be equal to g over 2r. Alright, I made one little mistake because I is not going to be, I is going to be equal to m, 2m as specified earlier in the problem times r squared. So that is going to mean that earlier this was a 2, so there was a 2 here, so that means this would be a 4, so that means this would be a 3. Actually, this would be a 3, so that would mean that has to be a 3 because we added this on both sides. Okay, so let's just plug that in, and when you plug that in, you get 6.5 seconds to negative 2. Okay, so now for part B. That's the answer. So for part B, what is the velocity of the man when he has dropped 20 meters? Now this is a little simpler. One thing, we could start with some of the initial equations you learn in physics. V is equal to AT and D equals to 1/2 AT squared, because V0 in this case is going to be 0. We know that D is equal to 20 meters and that the angular acceleration is 6.5 seconds to negative 2, and we also know that r is equal to 0.5, and why these values are important I'll get to in a moment. Remember earlier also that a is equal to angular acceleration times r. So those a's in those equations can be replaced by that. So we have a t, let's just isolate t in this case, 1/2 at squared. And when you isolate it, you will get that t is equal to 2d over a square root. So now that we know t is, we can plug t into one of these equations. Which one? So we plug t, let's plug it into, say, the first one. And we have v is going to be equal to this, the angular acceleration times r times 2d over a. We can plug all those values in. And that will give you 11.4 meters per second. Thank you for watching this. I hope it helped you out.